Hello, everyone. Thanks for tuning in to our webinar on empowering modern IT operations with observability. Today, our focus would be to understand how an observability platform can help IT operations or application management per se to streamline their processes and how an observability solution would be beneficial for any business, right? So, to understand the basics of observability, we already had a session done by one of our colleagues, and it's available on YouTube, where we get in depth on observability, give you insights into what observability does and why it is beneficial. However, in this particular session, we will be discussing about a few aspects of why observability as well, but also to understand why not a traditional monitoring solution over an observability, right? So this is a question that I've been asked in multiple conversations with our customers, telling that, hey, I already have a monitoring tool that monitors my servers and see any processes and services running on our servers, all of that. Why do I need an observability platform? Or it could be that, hey, I have a rudimentary application monitoring solution. Why observability? So I'll be answering that question. I'll also be getting in deep about observability, the challenges of just an observability platform, and the new kid in the town, or the new acronym, the full stack observability, what it does and why it is beneficial for a business, and why, say, enterprises or companies should look at a full stack observability solution. And I'll also be diving into the AI ops of things, where AI plays a major role in assessing and giving information that it gets from observability, and how that could be a beneficial tool for you as well, right? So without any further delays, let's get into the session. So as I told you, I've been asked this question a couple of times over and over again by customers, that why do I need to consider an observability platform when I have a traditional monitoring solution that monitors my servers, my network, and few processes and services that are running on those servers. Or at most, I've also had customers tell that, hey, I have some kind of an application performance monitoring solution, so why should I look at observability? And this is something that I kind of answer in a way where I say that application performance monitoring is a platform that collects information and gives you insight into an application, how it's performing. But if you want to resolve issues that are occurring within your application ecosystem, that's when you go and get an observability solution, or you try to build an observability solution, right? So to understand this particular aspect, I will take a scenario where we have a simple, or let's say a monolithic application, where you have a user interface that is connected to, say, an app one, that's the middleware, where you have backend processes that are running, and then you have a database that's connected to it. Now, what happens in a traditional sense with a monitoring solution over here is you would have an agent that would sit on top of your APM and collect certain golden metrics, right? This would be your metrics related to the load, that is a number of calls that are coming in and moving out of this particular application, the load time of certain data points and certain say calls that are happening, any errors that are occurring over there, right? And at times you would also look at resource utilization of that particular application, like say what's the CPU utilization, RAM, network, etc. So in a traditional sense, what the monitoring solution does is monitors this particular application and gives you information related to the performance of this application, and also considers certain metrics in terms of, let's say with the DB, it would be the query that's being called. So you'd get the information related to the number of queries that are being called for this particular DB, and the load time, right, the response time, etc., all of that, and the inbound queries coming in from the user interface. It could be your web mobile, etc., and the load time for that, and if any errors, right? That's pretty much it, what an agent or an APM monitoring module does once you have an agent set up over here. Let's say we expand this particular application into a complex architecture. Let's say we have a second user base over here, an internal user base. They're also logging in through a user interface, let's say a web application, and you have a secondary application over here, and you have certain microservices that are assisting this particular secondary application to kind of do some kind of load management, etc. over there, and then it's getting connected to the same DB, right? So what happens over here is, in a traditional sense of application performance monitoring, you would have another agent deployed onto your secondary application over here, and that again would monitor that application, giving you the perspective over here. So its connection to the second user interface, to the microservices through either API calls or any kind of rudimentary messaging services or something like that, right? So what happens over here is, whenever you have a problem, let's say this secondary application went through a development cycle and there was a new patch released over here, and all of a sudden what this application does is it is asking for multiple things from the backend services over here, and this backend services to engage this particular application is putting load on the DB by making too many requests, let's say 10x more requests over here. So that's kind of clogging your DB, and it's making the DB very slow, whereas your application one is struggling to get the information out of this DB, right? Now, what the APM monitoring solution does over here is it tells you that, hey, the DB queries are running in very slow, the load time of these are very slow, and that's the reason the application is not functioning properly. And one other thing that you would need to do is set up alerts on top of this, right? So if you had set up alerts on top of this, only then you will be able to understand that, hey, there's some kind of a problem and let me go. Now, what happens in a traditional sense when an SRE or a DevOps engineer looks at this problem is he would get in the alert telling that, hey, the load time is very high when the queries are being run, and the application is facing an issue. So let's say if I'm the SRE, what I would do is I would come down over here, look at this particular application, look at all the metrics, then go to the DB, look at all the metrics over here, then try to see what the issue is, because I'm not able to find any issue over here on the connection with the application, where I don't know what is happening at the DB because there's no way for me to understand what's happening over here. So in a traditional sense, what you would be doing is you would have another tool that specifically monitors the DB, and I would get into that particular application, look at all the information that is shown over there, number of connections that it has. So I'd see that there's a connection with the application one over here and connection to certain backend services over here. And there I would see that there are 10x calls that are happening from this backend service, right? Even now, I do not know what the root cause of this is, where I see these backend services are functioning properly. Now, what I do is I again peel another layer. It's like peeling an onion. So I peel another layer and I get into this application over here. So what I tend to see over here is once the new update came in, there was certain code changes that were done, and this particular application is calling in or asking for too much information from the backend, and that's the reason where it's pulling in a lot of information, or let's say the queries are being fired from the backend services, right? So that's your root cause. So the root cause is at application one, but you had to go through all these layers to understand what the issue is to get to application two and see the real issue over here. So that takes in a lot of time and effort. And you're losing about, say, a couple of hours or even a couple of days. And this could impact your business. Let's say your user one or this particular user interface is external facing. You have customers logging in over here. So it's a bad customer experience. They're not able to access, or there's a slowness in the application and they're complaining about it. So your user experience goes down, right? And let's say we complicate this furthermore, right? Let's say with a new kind of, not a new one, let's say the newer way of going through having your microservices, other services coming in, your message queues, etc., your Kubernetes structures where you have your apps being deployed on the basis of load, etc., right? The infrastructure gets very complicated, and it's a very kind of say disjoint infrastructure. This could be also related to say how your applications are kind of deployed. Let's say, is it on cloud, is it on private and public cloud, or do you have certain aspects of your application say on physical servers that are say in a secured location within your secured network, etc. So it becomes very difficult, right? So again, when it becomes very difficult, the aspect of SREs or DevOps guys to get into each and every layer and understand what's going on is also complex, and it takes a lot of time and a lot of patience for SREs. And as you know, your user experience is tanking as and when the time keeps on increasing for you to get in the root cause. So this is where observability comes into the picture. What we do is not just having a single agent deployed on an application or two applications rather over here. We would have agents sitting on all parts of these sections. Let's say there's an agent on your DB, there's an agent on your backend services, your front-end user interfaces, both let's say mobile applications, web interfaces, all of that. You also have agents on your message queues, backend services, etc. Now, what an observability platform does is it gives you an observability into all of these segments. Now, when I say it gives you observability into all of these, is you get to know that application 1 is facing issues because of application 2, because we are already monitoring the application 2 over here. We also know that this is sending in certain requests to the backend, and the backend is sending in 10x query requests to the DB, and that's where it's getting clogged. So observability tools are modeled in such a way that you will be able to find out what is the root cause of it, and through this particular alert that gets generated on application 1, without facing any kind of delays in terms of understanding what these metrics are, understanding where the issue is coming in, and trying to peel an onion, you get the information readily available to you through an observability platform, where it gives you a simple alert telling that, hey, your DB is running in low, and particular alert from the DB. So since we are monitoring the DB application over here, where the DB tells that, hey, I'm getting in a lot of queries from this, that's the reason I'm clogged up. And once you are monitoring your backend services, it would tell you that yes, that particular query request that I made was from application 2 for a particular process or something, and that's the reason. So you get a whole chain of events recorded, and observability platform provides you with all those kind of say traces of how this particular issue propagated from another application that does not have direct connectivity to the application over here, but it did affect say application 1's performance, right? So that's how observability was kind of came into fusion, and yeah, that's how observability is. So to recap, your APM gives you metrics where you look at the health of each and every application, but what you do not have is the insight or the ability to understand what's happening with these metrics, how are they linked. So that's where observability comes into picture and gives you an overall view of what is happening. So understanding about the metrics, how they are linked, and rather than you kind of as an SRE or a DevOps person sitting in and trying to understand what's happening, observability tool gives you that information, and that this is what has happened, and this is the root cause of a particular issue, and the only task at hand is right now to fix it. So that's where you get in the observability part. So moving forward, let's understand what observability is, what are its challenges, right? So even though it gives you understanding into metrics, there are certain challenges that observability tools also face, or observability in general faces, and how A full stack observability solution can overcome those. So, what are the key challenges that observability solutions do face, right? So, observability, as I explained you in the last slide, is kind of an addition to APM, and it gives you an understanding of the metrics and what's happening. But there are certain key challenges that we'll be focusing over here, is in terms of vast and heterogeneous data sources. What does that mean is you have a huge application ecosystem. As I told you earlier, it could be on private, public cloud, and you also have an on-prem setup running, and all of these applications are interconnected and talking. Let's say you have Kubernetes, about say certain dozen clusters and hundreds of pods running, and you have microservices that are running on-prem. So as you know, right, it gets very complex and complex. And with that complex nature of applications and the ecosystem that you're running, you have a vast amount of data coming in. Those are your metrics, and that information is very hard to look into manually, right? So you would need assistance from tools where you need to make sense of what this data is. Let's say the metrics, right, coming in. To piece them together to understand if there's an issue or what is the issue exactly and how to fix it. So that's the main agenda, is to fix an issue, right? So to understanding an issue, if it takes a lot of time for you, you're losing your time over there. Your mean time to resolve drastically increases, and again affecting a lot of other metrics in the business, your user experience, churn rates, all of those things, right? And again, system complexities, signal complexities, you have multiple signals coming in, you have multiple alerts coming in, triggering in. Even with having an observability platform, if say you set up alerts, or if there are alerts configured on each and every layer, you are bombarded with a lot of alerts, right? How are these alerts relevant, right? So if you get in 1,000 alerts for a particular issue, let's say you get in 1,000 alerts, you dig in deep, you look at all the metrics, you piece all the information through the observability, and at the end of it, let's say an hour or two has gone, and you're like, oh, it's just a single issue that's kind of propagated through multiple applications and multiple resources, and you've gotten thousands of alerts. It could have been a single alert that could have come in, and you could have just looked at a single alert, understand what it's affecting, or see the base issue, how it has propagated to other applications or microservices, and why those are getting affected, right? A single alert, basically. And you also have an issue in terms of aggregation and correlation of all of these data points and signals without losing it, right? Without losing the quality of the data, all of that. So observability tools also tend to be very intensive in terms of getting in data. And one of the other issues over here is when you have huge sums of data coming in, and it costs you a lot, right? So holding the data, processing the data is a cost factor, and that's also something that we'll be looking at. And also building and maintaining a real-time data pipeline. Now, say if you want to build your own observability, there are tools out in the market. There are free tools that are available, like your Prometheus, Grafana, all of those things. It gets very difficult for you to manage, right? You need a dedicated sort of resources, people working, setting up these dashboards, setting up these signals through Prometheus, configuring the agents, the data collectors on these applications, all of that. And as I told you, the storage, balancing the storage costs with the historical data, and how much historical data is required for you to analyze certain information, etc., right? So all of those also are key challenges that observability tools face right now. So let's get into a use case scenario and try to explain how a full stack observability tool, along with AI ops, AI ops, in this case our own solution, which is called as cognitive AI, would help alleviate all of these challenges, and how Recurrent Six Sense with our AI ops is trying to kind of democratize observability through our full stack observability coupled with CogAI. Again, full stack observability is kind of an acronym. It's kind of another iteration of observability. So, in the same concept, how APM has another layer that kind of got developed and it was called as observability. Observability has another layer that got developed and it's called as full stack observability nowadays. So to understand this, let's get into a particular use case. Let's say you have, let's take in a use case of a retail or an e-commerce platform. So a typical e-commerce platform would have your user interface applications. So this could be a web, mobile, etc. So both iOS and Android user interfaces. Then you have something called as a catalog search engines that are running. And let's say you also have a cart services that holds in all the information related to the products that the users are purchasing. Then you have a checkout services where all user related information, the delivery addresses, the billing address, and all the other information related to the payment source, etc. And also, you would also be connecting to an external payment vendor or an internal payment application that you have. So this is a very basic setup. I've just highlighted a few of the say applications that would be kind of involved in a particular user flow. And let's say these are all microservices. You have multiple say instances for all of these applications, either for load balancing or either based on locations. Now again, the complexity has increased with microservices, right? Say if it is location based, if it is for load balancing, etc., you'd have hundreds and hundreds of microservices. And let's say if it is on Kubernetes, it would be even more complex, right? You'd have pods that are spinning up, that are being killed, that are being restarted for multiple sets of reasons, and based on the configurations that are done on the Kubernetes, right? Let's say these have a complex nature in terms of the way that they are developed, right? So it can be an Angular for the front end or through Swift or PHP for web, right? And your backend applications can be using Java, Elastic for the DB, and you have API services, etc. that are running. So the complexity increases even with the way that these applications are developed. Now, moving ahead and to understand how these complexities and everything is kind of causing an issue, and how full stack observability comes into the picture, we'd also need to understand another layer in terms of infrastructure, right? As I spoke in the earlier slide, I was talking about see the private cloud. Let's say for this particular scenario, we have the catalog, the cart services, and the checkout services are on a private cloud, whereas you have see the payments. Let's say it's a third party application that you're getting connected to a payment application or a payment vendor, and you also have your front end user interface that's on public cloud, right? So it's again a complexity over here where you have certain private and public clouds. Now, considering all of these complexities, let's say if you go with the traditional APM plus observability solution, what you'd be doing is you'd only be covering certain solutions. Let's say only your private cloud solutions, that to a limited to let's say the technology. Let's say it only supports Java. Or Elastic, only API, and you'd be missing out on certain technologies. So there are a lot of variables and components that either you miss out. Say a few of the times you would not have the expertise to monitor, let's say, the private cloud or the public cloud, right? And you don't know how things are affecting through your infra layer, that are kind of propagating into your application layer and interconnectivities over here, all of those things. Now, what do you do when you have that kind of an issue? That's where the full stack observability was kind of thrown into the mix, where you kind of monitor everything within a single pane of glass. When I say that, you monitor your applications, be it any kind of technology, right? And on any kind of infrastructure layer, be it on-prem infrastructure, cloud infrastructure, private, public, whatever, right? So that's where full stack observability comes into picture, where you get into the nitty gritty of understanding everything about your application ecosystem. Now, with that, let's get into understanding how AIOps helps you over here. Now, again, when it comes to full stack observability, all the core fundamentals are there that are kind of coming in from your monitoring. That is your basic alerting, looking at metrics, all of that. Observability, just as a recap, observability would give you traceability, gives you the lineage of a particular issue, how it propagated from, say, one layer to another layer. Whereas full stack observability takes it kind of a step further or a notch up, where it looks at not just one set of applications or one core group of applications, but everything and anything that you'd want to monitor. Let's say it different infrastructure layers, different say language based applications, and throughout pretty much any complexities, right? Be it on Kubernetes, be it on your, say if it is a bare metal application, bare metal server, which has an application on it, or it's a microservices application and they are getting connected internally. So all of that, right? So full stack observability is kind of a single pane of glass that connects all these things together and give you a single pane of information to look at. So rather than you going into multiple other tools, looking at what's happening, all of that. Now, to understand how all of these are getting developed, you need to basically understand what's happening, right? What's happening with monitoring, observability, and AIOps. In the same fashion that I explained, what we are looking at is the monitoring is a core layer where we are getting all the signals. We are looking at better quality outcomes that are coming in basically through your agents that are collecting information. Whereas observability is a domain level that gives you diagnostic intelligence to reduce mean time to resolve, right? So giving you an intelligence layer, basically. Observability platform is just to give you an intelligence layer. Whereas AIOps or AutoOps over here is for you to look at how do you be proactive in nature. So up till now, whatever we have seen in observability and monitoring is us reacting to issues or reacting to certain anomalies that are occurring, right? So what are these anomalies? Let's say something's happening to one of your application due to infrastructure flare up where you have high CPU utilization, a particular microservices gone haywire, you're getting an alert and you're reacting to it. So let's say you got in an alert, it took you about 6 hours just using a monitoring platform, right? Your business is down over there, you're getting a lot of bad reviews. Let's say you have an observability platform with the same sort of issue. So rather than say consuming about 6 hours, you've just found out the issue within a couple of minutes and taken about an hour's time to fix it, right? Even an hour at this day and age is a lot of it's a lot of time, right? And you do get a lot of losses that gets recorded even for an hour of downtime of a particular website or an application, right? So to avoid that, we have the AutoOps layer. So this is where we are trying to predict if something can happen based on say historical data. And again, I'll be explaining you in detail on how we would be doing that, or how AIOps from Rakuten Sixth would be doing that in conjunction to our full stack observability in the next slide. So yeah, AIOps is kind of a transforming intelligence layer that gives you actionable insights to proactively look at what's about to come, right? So, and also to give you insights into, let's say, resource management through forecasting, right? So all of those things. So also you're not just looking at solving issues, you're also looking at scalability over here. So getting into the next aspect of AIOps, first we would need to understand what are the typical challenges that you have when it comes to IT operations and how AIOps is trying to tackle these particular kind of say issues. So first and foremost, we are looking at missing of alerts. This is something that is very human in nature. Say you're getting certain alerts coming in, let's say 6 a.m., 1 a.m., uh, and you don't have your engineers or site reliability engineers looking at the screens 24 by 7, you miss an alert. And that causes an issue, and you have downtime, right? And again, you have issues covering 24 by 7 over the weekends, all of that. So all of those issues are a concern for you. And also configuring these alerts, right? So let's say you have 20 Kubernetes clusters, about 100 applications with 500 microservices that are running. Configuring for each and every parameter, let's say the load of one of these applications, which has 10 or 12 microservices, and as you can see, there's a scale, right? It becomes a very big hassle for you, right? Very big hassle where you need to configure each and everything. And third most important thing is a lot of alerts coming in, right? How do you look at which alert is important and which are the alerts that you need to kind of let go of, that are not required? Even though you feel, if it's let's say when you're configuring, you would feel that this particular alert is important, but it may not. So we have done that. I've done that a lot of times, configuring alerts where I feel that this alert is required, where I keep on getting that alert, but nothing breaks, right? So those are certain kind of situations that we are trying to tackle with AIOps over here. So to recap, so 24 to 40 week setup, again, for configuring alerts, and 100% dependability on resources. So any kind of observability platform, you would need to have a person who's looking after that particular solution, right? And that's another dependency that we are trying to reduce, where we are trying to move away from dashboards, just only get alerts from the AI engine. Artificial intelligence over here would just suggest or give you insight into telling that, hey, there's a particular anomaly that's occurring. It is linked to a particular set of applications that are crucial for your business. Would you want to take a look at it? Rather than you sitting in front of a screen monitoring a particular dashboard, trying to see if something goes wrong, or trying to see if there are any alerts that are getting generated, right? So totally trying to say not have dashboards as a menu. Obviously you would need dashboards to kind of drill down, look at what's happening, try to understand what's happening, but as an initial go, it would be taken over by the AI applications, looking at the dashboards, kind of only suggesting you if there is a critical issue, or kind of notifying you if there is a critical issue, right? So moving in, how do we do this with cognitive AIOps that we are presenting over here from Rakuten Six Sense? That's where we are taking pride in terms of coming up with next gen solution for observability, where we would be getting in signals again, as I showcased in the previous slide, where monitoring, observability are core layers. They are required pretty much. But what we are doing with AIOps is kind of an overarching layer on top of all of that, right? So with all of that metrics and the intelligence that's already gathered from monitoring and observability layers, what we are doing over here is trying to take that historical data from those platforms, trying to forecast. When we are doing forecasting, what we look at with AIOps is trying to find out those small changes that are occurring within the data sets that we are looking at. So this could be time series data. This is rather time series data that we'll be looking at, where we'll be seeing the spikes that are going up, the spikes that are dipping down, right? And trying to analyze the pattern of the particular application. So that's where we detect anomalies, basically. So say, for example, over a past year or two, an application has behaved in a certain way. This is again through seasonality. Let's again take an example of an e-commerce platform. Let's say the e-commerce platforms usually get high flow of traffic when there is say any festival sales or Black Friday, for example, right? So that's where your seasonality comes into picture. So the AIOps tool, our cognitive AIOps, would look into the seasonality of it, try to know when there is a spike, let's say high usage going on, low usage, etc., and gives you an anomaly detection range where it can predict if there's low utilization or high utilization of a particular metrics or a time series data and kind of flag you off. So at any given point in time, if a particular application is not within a particular feasible range, or it's not behaving, or the metrics that it's loading up are not within a particular feasible range that the tool has looked at through the past data, you'd get a flag off over there. So you'd get an alert where it would state that, hey, there's this particular application on this particular microservice is deviated from its permissible range. Would you want to look at it, right? At this point in time, nothing has happened. It's just flagging off, asking you for an input. And again, this is where the ML engine kicks in, where you'd given the inputs and it would register this as an anomaly so that it can detect this, say, sometime in the future. Now, how does it do that, right? So once you've given the input, it records that as a feasible anomaly, stores it, and anytime the same set of patterns are occurring on that particular application, it would flag it off as an alert to you. So at that given point in time, it's for sure. Again, this is based on the input that you've given. The ML engine has recorded this, and you would be getting those alerts in. Now, automated RCA and healing is something that we are working on in terms of getting you the root cause analysis. So automated RCA is just to give you an insight telling that, hey, there were 400 alerts that have come in, or 400 anomalies detected, but the root cause of this was this particular single anomaly, let's say a payments service that was running at the back end that caused this issue, and it kind of propagated, right? So giving you all of that insight with a single alert, and also telling you what are all the other say application and resources that have got impacted. And auto healing would be where we would be trying to resolve this issue. So either it could be a small configuration that was done to rectify the issue or something. So that would be recorded within the platform, and as and when a particular anomaly is detected, and we would see that, or the tool would see that the application is about to fail, it would do an kind of say proactive healing, where it would do those particular steps through scripting or something, try to do those configurations and try to avoid a particular collapse over there. So that's for automated root cause analysis and healing aspect of things. Now, we'd also look at impact prediction and pattern matching. This is something for you to look at, say, for forecasting needs, etc. So again, expanding on resources, this could be your infra layer, all of that. So it would be very handy over there based on number of users coming in, the load happening, right? So giving you an analysis in terms of what you could expect into the future. And also to look at misuse of any misuse that's occurring, right? If there is a particular application, it's going out of a particular set of configurations that you're kind of set in, and it's not acting within a kind of a say laid out law. For example, let's say you have an application that should only send in requests to a particular microservice A, but it's all of a sudden sending requests to microservice B, or certain API calls are being made for an external source or something like that. So that is kind of an anomaly. We can detect that as well and kind of flag it off to you. So any kind of misuse in terms of your applications, the connections, etc., also can be flagged off. So that's where we are at with cognitive AI. We are, as of now, taking requests for demos for this particular tool. And again, we are also having a lot of content on our YouTube platform for you guys to have a look at. So please do subscribe to our YouTube platform. And yeah, hopefully this particular session was educational enough for you guys. And yeah, see you in the next session. Thank you.